Hello everyone and welcome to my video on solving quadratics by taking the square root. Taking the square root is a useful way of solving when your quadratic is in certain forms. One of those forms is when there is no bx term. So if you take a look here, you'll notice this quadratic is ax squared and c, no bx. So if you're solving by taking the square root, the first thing you want to do is make sure your quadratic is equal to 0. And then once you have that, what you want to do is you want to start getting the x squared term by itself. And that's going to look the same way as if it was an x term, right? In this case, you want to cancel out that plus 84, so you're going to subtract 84 on both sides. That'll give you 3x squared equals negative 84. And then what you would want to do is divide both sides by 3. Right? So this would look the same as if you were solving for an x or an x squared, right? There's no different at this point. And you get negative 28 when you divide by 3 there. Right? Can't forget my square. Now, from here is when things start to look a little different. Right? If I want to solve for x now, I have to get rid of the square. So what I want to do is cancel out the square by taking the square root on both sides. Square and square root are inverse functions, so they cancel each other out. Now, a big important part of this is when you are taking the square root, you're the one putting the square root in. You want to make sure you add a plus or minus in front of that square root. And it's very important that you do that. All right, so I don't need to do it to the one side. I don't really have to worry about that left side in terms of adding the plus and minus. Now, on the left side, x squared, square rooted, the square and square root cancel and leave us with x. On the right side, we get plus or minus the square root of negative 28. You're going to want to simplify that. There is a quick little refresher video if you forget how to do that. But once you simplify that radical, you will end up with 2i root 7. All right, so our answer to this quadratic is x equals plus or minus 2i root 7. So that means there's two answers, a positive 2i root 7 and a negative 2i root 7. All right, so there's our two solutions to that quadratic. All right, so let's take a look at the next example. So again, taking the square root is a useful way of solving if it's like the first example where there's no bx term, or if it's like the second example here and the third example that are in vertex form. Vertex form is the form a times x minus h squared plus k. Again, you want this equal to 0. And you're going to do something similar to the first example. You're going to get the squared term by itself. In this case, it's an x minus 3 squared instead of just an x squared. So you're going to subtract 60 on both sides. And that's going to give us negative 5 times x minus 3 squared equals negative 60. And you're going to divide both sides by this negative 5. All right, so that looks very similar to example 1. And that's going to leave us now with x minus 3 squared equals 12. Now at this point, again, I want to get rid of and cancel out this square. So what I need to do is square root both sides. And on this side, square root, and again, adding that plus or minus, right? So you got to make sure you add a plus or minus when you're taking the square root. All right, so on this left side, they're going to cancel. The square and the square root equals plus or minus root 12. And again, you're going to want to simplify that radical. So that radical is going to simplify into plus or minus 2 root 3. And I still have that x minus 3 on the left. Now that I've simplified this square root, I can go ahead and get x by itself by adding 3 to both sides to cancel out that minus 3. And my final two answers are x equals 3 plus and minus 2 root 3. Right, so 3 plus 2 root 3 and 3 minus 2 root 3. Right, so let's take a look at example 3. It looks the same as the last example, except instead of 60, it's 45. So we're going to go ahead and go through this. So I'm going to subtract 45 on both sides. That gives me negative 5 times x minus 3 squared equals negative 45. Divide both sides by negative 5 to cancel that out. And we get x minus 3 squared equals 9. And similar, square root both sides, remembering to add a plus or minus. And I get x minus 3 equals plus or minus square root of 9. Oh, but the square root of 9 is 3. All right, so this problem is a little different because of this. All right, so let's take a look. The next step is going to be the same thing. I'm still going to add 3 to both sides. And I'm going to get x equals 3 plus or minus 3. Now, it's different because since the radical simplified completely to an integer, I can keep going. I'm not going to stop here. Right? I can take this and separate it into two separate problems, one where it's a plus, so 3 plus 3, and one where it's a minus 3 minus 3. Right? And that gives me 6 and 0. So I get my two answers, x equals 0, comma 6. You want to make sure to simplify to the max. That's why we simplify the radicals. And when it simplifies to an integer, you're going to actually use that plus and minus to calculate your final answer.